Okay, so you're going to start out with your board like this, and I'm just wearing gloves because if you wear gloves then you don't have to wash off the solder paste or any residues afterwards. And the first thing you want to do is get some like scrap boards that you don't really care about, and make sure it's about the same thickness. And then what you're going to do is you're going to put the circuit board, you're going to solder stencil about in the middle of all these, so that your board is held firmly in place like that. And then you're going to get 5 pieces of just like tape. This is Scotch, like masking tape. Yeah, so it doesn't really matter. So I'm going to stick a piece right here. Yes, that's good enough. I'm going to stick another piece right here. Another piece right here. And then a piece back here. All these pieces have to do is just be able to hold your board in place firmly. So that seems like it's a little loose. So I'm just going to do this one, and this one also. This one right there. Okay, that's a little bit better. So you can just wiggle your finger back and forth and you'll be able to tell if it's secure or not. Then he'll take your stencil. This is just the transparency with the solder mask, with the solder paste or the solder cream cut out into it with a laser cutter. This is using an old design, but all the features are still in the correct positions, so it'll do. So you line up the stencil with the yep, just like that. So you line up the stencil with where the solder will be going, and then you just stick a piece of tape on one end like this. Make sure that the holes stay lined up, and then once you do that, you'll want to form a crease back on the edge of the stencil, just so that it folds more cleanly. This isn't necessary, but it's just something I like to do. So once you do that, then just double check if the holes are lined up. Very good. Now, when you lay down the solder, you're going to peel it back like this so it doesn't disturb the paste at all. And I'll show you how to do that. Okay, so you're going to take your solder paste, which may be like a syringe. This is ChipQuik, or maybe like a little jar or vial, like this stuff. Either way, you're going to take your solder paste, whatever brand it may be, and I'm just going to use this, but I'm going to detach the little nozzle on the end because it's very hard. It takes a lot of force to be able to squeeze all the solder paste through there. So I'm going to just take this, and I'm going to put some daubs of solder paste about where they should go. Okay, so I'm going to screw this back on here. So one thing I forgot to mention, so with the HELA board, it's going to generate a lot of heat. So we want to fill up these these vias with solder, so that there will be more metal to conduct the heat. So what I'm going to do is I'm going to take this syringe and just squeeze some solder paste through these holes. Alright, so it looks like on that side. I'll just go a little bit more. So I got some excess on that side, so I'm going to take my razor, and I'm just going to kind of smear it through, like that. And hopefully the solder paste will start to come out on the other side. I'm actually sandwiching this down like that, pressing it down to help force the solder paste through. You just smear off the excess on both sides. Okay, that should be good enough. We'll see how it turns out. Let's just stick that back in here, and then we'll go on to soldering the stencil. Okay, so you'll want your solder stencil to be laying down, and just double check to make sure the holes are all lined up. There's a little bit of solder paste here from a previous trial, and all you're going to basically doing is you're going to be taking your syringe, and you're going to be going over putting some globs down on the pads you'll be soldering, or where you'll be going to be placing parts in the reflow oven. It's okay if you don't get it perfectly lined up, because we're going to be spreading this out with the razor pretty soon. So let's take a razor and start scraping this across. You'll probably want to make sure that the angle of the razor or the spade or whatever you're using is less than 45 degrees, so it forces the solder down instead of just pushing across. You might also want to try different directions. Once you start to fill up the holes, then just kind of like scrape off the excess by having the razor at a higher angle, a steeper angle, like greater than 45 degrees. But be careful not to accidentally pull out solder from other holes. Alright, so once you've done doing that, then carefully lift the stencil from one side and kind of just like curl it upwards, and that will not disturb the solder down there. Alright, so if you have some extra solder paste on your razor or your spade, then just set it aside for future stencil wipes. And if you're all done with it, then you can just put it back into a container for future use. Now, on this board, we have a little bit of extra solder paste, so all I'm going to do is just take a stick and just kind of wipe this up like that. Also, with these 6 pads right here and right here, so 12 total, that component uses soft plastic which will melt in, so right here and right here. That will use, that component uses soft plastic which will melt in the reflow oven, so I'm just going to scrape those off for now, except for, no, I'll just scrape them all off for now. Okay, everything else is looking good so far. I'm just going to put that excess solder paste onto that razor, which, to be used later. There's some little smears left over. You just take like a Q-tip and wipe that stuff up so it doesn't, so it's not soldered onto the board with the rest of the stuff. If you don't get all of it, that's all right.
Oh no. Oh no. Are these mostly milk balls? No,
Okay, so that looks good enough. We have paste basically going everywhere we want it to, basically. If it's not aligned perfectly with the rest of the components, that's fine, because solder has a very high surface tension, and so it'll go to other surface. It'll go into places where it can, and where there's it'll either stick to itself on terminals, or it'll be contained by these walls of solder mask. So now we'll be laying down the parts. Okay, so now we're going to be placing the components, and for this board we have, we're only going to be putting down 3 components for the reflow oven. We're going to be putting down some capacitors, and some inductors, and the HELA 10 power amplifier. So you're just going to take some tweezers, and then carefully place the components where they should go, and then press down lightly into them so that they kind of get mushed into the solder paste, and so that it makes like a clean connection, like a uniform connection with the component. You also want to make sure that you don't kind of push around the solder paste too much, or otherwise it might be distributed in ways that it won't reflow correctly later on. Oops, I made a mistake right there. That's not supposed to be bridged. It's supposed to go right there, and this guy is supposed to go right here. So, yeah, I'm just going to push a little bit of solder around so that I have enough there. Okay, so those are the capacitors, and then I'm going to lay down the inductors. There we go. Let's push it down a little bit so it's firmly in the paste. Now for the HELA, which is a semiconductor device, it's an amplifier, I'm wearing a wrist strap to keep myself grounded so that I don't have like static electricity that could build up and damage or destroy it. Let's see. So I take that, and I'll just flip it over, and I'm going to just carefully place it right about there, and just nudge it around a little bit until it's in place. Alright, so that looks good. And I'm just going to push down slightly into it so that it makes a nice firm contact with the paste. So that's what the board should look like before it goes into the reflow oven. Okay, so now we're going to take the board, and we're going to lift it carefully without disturbing the components. Like, there's pretty snugly on there because the solder paste is sticky, but make sure you don't drop it or anything like that. So we're going to take it up to the reflow oven. And you're just going to place it about in the center. Do not place it on any kind of pieces of ceramic that elevates it, because that will get it too hot. Then you'll just close it, turn on the oven. Then you'll press F3 once, and you'll see that says wave 1 right here. We want to select wave 3. These are the temperature profiles, gradient profiles. So this is time down here in minutes, and this is temperature right here. I believe in centigrade, because this is a Chinese reflow oven. So F1 is go right, so wave 2, and we want wave 3. So this goes up above 250 degrees, I believe centigrade, which is what we need to be able to reflow the solder paste. You're going to press F4 a couple times, and it'll take you to like this alternative menu. You'll just press F4 again to see everything else. Once you've done that, you'll press temp wave autoexec F1, and it should say F3 up there. And then once you do that, then the infrared lamp will start to turn on, and it'll show the elapsed time right there. Also, as time progresses, the reflow oven will display the little markers on here. That's showing where the actual temperature samples are. So there's a little cross right there, and in a couple of seconds it'll display another one. So it's basically checking what the temperature is inside, and then it's either turning the lamp on and off, or turning the fan on and off to control the temperature. So there's another little cross right there. So it'll follow this temperature profile until it's done. And when it's done, all the solder will be reflowed, and we'll be able to pull our board out. So after it's done, just take it out and inspect it. It's going to be pretty warm afterwards, so that looks good. I don't see any burning. Just make sure you grab some like tweezers or tongs. Maybe a little bit stiff. Let's check the back. Okay, so it looks like the solder melted through. I know there's still some air bubbles, but if that's a problem in the future, we could just use some solder paste to fill those cavities up. You can see that all of the solder reflowed into the places where it's supposed to go. So even though it's not very pretty, it looks like it's done its job. Okay, so inspecting the board afterwards, it looks like we have a bunch of beads to clean up, so we'll just take some IPA, isopropyl alcohol, and we'll take a horsehair brush, and if necessary a pick, to scrape out any extra solder beads or extra residue. It looks like that all these have soldered properly so far. I'm not seeing any shorts so far, but I did notice that right there is a little solder bead, and so that'll probably be broken out as we clean this board up with a horsehair brush, an IPA, and a pick.
Okay.
Okay, so you just take your horsehair brush and your bottle of IPA, like that, and you just hold the board down, and then you just scrape along all the edges, all the corners, just to break out any loose balls of solder, and to remove any residue of flux left over from the solder paste. And then you want to go and do the back also, just make sure that there's no more flux left over. So looking through this board, I'm just looking for any shorts between the signal traces and ground that could potentially destroy the quality of the output RF signal. Looks like that we don't have any traces between ground, shorts between ground and the 12-volt input right there. It's okay if there's little balls of solder on the, or little blobs of solder on the various bits of exposed copper. Okay, everything looks good there. And now I'm going to be looking in between the leads, and I don't see anything. Looks like it all lined up all nicely. I don't see any solder beads underneath there, which we've had problems with before. No solder got into the screw holes. Okay, everything looks clean there. Okay, everything looks clean there. And just going back on the other side.
You feeling better? Yes, I am. Excellent. Great. And sometimes they got cookies as well.
Okay, that looks good. Sometimes electrical components will be raised like this, which I like to call tombstoning. That just happens when there wasn't a good connection, like a good spread of solder paste onto both the leads of the component. So afterwards, you'll just want to solder on the soft plastic components, like these little transformers, and we'll start by just putting like a little solder blob on a small piece of copper. So I'll just start on this corner right here. So that's a little blob right there. Then you stick on the part, and then just keep that spot molten while you line the part. And just going to adjust a little bit. Just a little more. Okay, that's good. So then we'll tack down the opposite end so that its orientation is fixed. And then we'll just go on to solder down the rest of the leads and do that for the other transfer. And we'll go on to testing the board.